Right, I'm just keep refreshing. Right. So you understood what do you what about I mean what do you define about the job, right? So data stage jobs, server jobs, parallel jobs, mainframe jobs, but we are just concentrating on parallel jobs. Okay, right. Server jobs and the parallel jobs difference also we have seen because architecture especially it's purely works on SMP, but whereas your parallel jobs are works on MPP. But when you see your real time, you are, I mean, even IBM Datastage is going to work with both SMP and MPP architectures. They're going to do that basically inside of that architecture, I mean, server end. Why? Because maybe some volumes of the data, maybe you're processing initially. Maybe in other jobs you're processing high volumes of the data. Why to go for an all process to be, active mode? That's the reason. Always process will be in active mode only. But the thing is, why to waste of that performance or consumption of the processes? That's the reason they'll use both our SMP and MPP architecture whenever the limitations they're going to provide. This much of volumes of the data it's crossing, obviously it will choose SMP or MPP. So it all depends on that. Okay, that's fine. That's the business basically. Right. So even it is having more number of components compared to server jobs, and it applies parallelism. I think we have done all these things, right? Built-in stages, active stages, parallelism techniques also we are talking about, right? I was supposed to talk about entire partitioning if I am not wrong, right?
Yeah, you are right.
Okay, fine. So let's talk about once again partitioning methods. Auto is nothing but it's automatically your processing will be done. You don't require to do that. Server will take care of that. Data to server. All the records are going to be shared across the processes. Your data to server will take care of that part. Hash is nothing but it's first similar records will be making into the groups. I mean, it will be grouped. So if there is no similar records, obviously one record will be passed into the one each group. Okay. If any records are similar, records means based upon the key column or whatever it is. Hash will work on key column based on the hash algorithmic key column. It's a function called algorithm. Algorithm is grouping basically. I think you might have read in earlier of your engineering or somewhere algorithms, right? So maybe somewhere you might have. So it's grouping concept. Modulus, as I told you, it groups the data, and inside of the groups the data, it will minute calculation which business is required. It will go ahead, right? Say suppose 3 records, similar records are there. So you are making into the group. How many groups are there? 5 groups are there. 3 by 5, it's going to be something 0.6. Either your business purposes, whether you require 0 or after decimal 6. After decimal, there is a value, high value called 6, whichever. It's all. So that's how you modulus, but you don't much go for modulus. In some very rare cases, you'll go randomly. Your processors going to pick the records. The processor will pick the records. Yeah, reverse way. Okay, range is nothing but range. Also, you don't use it mostly. Round robin. Round robin is the fastest and best process. I mean parallelism partitioning technique. And out of all the this one, because it's very speed. If you talk about round robin is in a cyclic order way. First record must goes to the first processor. If not, second processor. It will check if all the records have been occupied by the processors, so no space for the records. Then obviously it will check for the next level. So that's how cyclic way. It maintains some order. It's a particular order, but that's how. Same as I told you, same partitioning method is previous partitionings. If you are used it, So those will take into the picture for the next level partition, next level stages. That's how same partitioning will work, right? Entire, yes, we are coming to that part. DB2, as usual, it's a common for DB2 database. Either it could be a source or it could be a targets, right? Now let's move on to the entire. So it's very, very good concept over here. Please be concentrate. Because here we are trying to cover some stages concept here, okay, while we are talking about. Yes, entire is basically, it's a partitioning method where when you are going to differentiate or where you are trying to combine, where you are trying to join, then entire partitioning will come into the picture. Basically in Datastage tool, there are 3 processing stages. If you want to see here, let me check it here, whether the services got on or not. There are 3 stages which comes under processing stages, right? Which are join stage, lookup stage, merge stage. What are those?
Join,
Lookup, merge stage. Basically, those 3 stages will be used for the same purpose, or matching and unmatching records to capture only, but only differs of the volumes. Volumes, based upon the volumes only, whether you can go for join stage, whether you can go for, the stage called whatever, lookup stage. Otherwise, you will be going for merge stage. That you are going to decide it. You see here, these 3 stages: join, lookup, merge. All these 3 stages will be used to see the symbolics also. You can understand this. It's inviting minimum 2 inputs. Lookup also will be invited for 2 inputs minimum, but more than 2 inputs as well. Merge stage also, see the symbol. It's trying to join. All the 3 comes in the processing stages. All 3 stages will be used for the same purposes, like joining the multiple sources, but it differs volumes. Based on the volumes of the input data, either you can go and decide either join stage, otherwise lookup, otherwise merge stage. The competitive stages. So performance wise, which is the best when you're trying to join, you have to decide. The business will tell you, you can confirm with the business. Out of 2 inputs, say suppose 2 inputs, which input is having higher, so then you will decide it, which stage you have to use it, and which partitioning method you have to use. There you can decide. That's the reason I'm trying to talk about entire partitioning, whole the thing. So let me complete this one. Right. Let me start with the join stage first. Join stage required 2 input sources. Say suppose it requires more than 2 input sources, but joining can be done even with the 2 input sources. That's how I'm trying to do that. This is our first input source. This is the second input source. I have joins. Okay. I'm just mapping first input source to join stage and second input source to join stage. Now I'm just doing that matching records. I'm trying to matching and unmatching records to capture between it's happening under this join stage. Okay. When you try to do joining on between the 2 input sources or more than 2 input sources, you will get only single output. As you know that join stage will have the join types, right? Join stage will have what are the join types? Inner join, right? Right?
yes,
Left outer join, right outer join, and full outer. These are the join types are available in the join stage. You can have a more than two input sources you can join, but as of now I'm trying to show it two input sources. Obviously, when you're trying to use join stage here, one input source, first input source, whenever you're trying to touch to the join stage from the first input source, obviously it is going to be read as a left link. Whenever you're trying to touch to the next input source, it will read as a right. That's a see naming convention, left outer join, right outer join. That's a naming convention. Obviously, it is going to be default naming convention for the links for the join stage. The data stage will read it. If you want to see here, see, I'm just going to take both input sources. I'm taking as a sequential file. Either you can take the table also. See here, and I'm just taking the two input sources. I'm pulling the join stage here. Let me understand you. Say suppose if you look at the join stage, some key will be there. Default types are how many options are there? Inner, left outer, right outer, full outer. Just now I written right over the pane box, right? These things. But you have to define based upon the key column only, right? Obviously. Now link ordering. See here, nothing will be there. Left and right. If you touch here, first link, obviously, if I touch, even if you touch here, this is going to be left. But I am going to format. I'm always, you have to follow one way. Sorry. Let me pull once again the stays. See now it will read as a left. DS link, which one? 7, right? DS link 7 will become a left. See here, DS links left. So now you can rename it. This is going to be left. Okay, right. Then it is going to be a right. DS link. You wanna see? DS link has become a right. Right? And as I told you earlier, you can merge more than two input sources. Still you want to bring some more input sources, you can bring it. You can bring it. Then what is the advantage and what is the disadvantage? I'll let you know. First of all, I'm trying to show you that design part. Here if you see here this link 10, so it is going to be intermediate links. Now you can see here right link will be changed to the, it will be, it should be an intermediate link because you have made it, but it will become a right link. Let's see how it goes. See here what I'm trying to say that just a moment. Let me complete here. So who is that? Just a second. Okay, fine. So what I'm trying to say here, right became intermediate. You can change it, order you can change it. Select it. Right, intermediate obviously this. So you can join multiple input sources. What I'm trying to say here, multiple input sources, but join stage is always better to go with. You can group the tables. You can merge over here. Better to use it. And also performance-wise, go with two input sources, and output will come single output. Again, go with other tables up to maximum 8 or 9 joins in a single job. Single job you can use it. A single job you can use just a moment. Just a moment. Just a moment. Let me. I think from office some issue has come. Support issue. Just a moment, Sharon. Just I'll be back. So I have some call from office. I'm just picking up the calls. Right. Sorry, guys. I was talking about something here. Yeah, jobs. Right. Yeah. Yeah, so you can make how many things are going to be there. So you can make it. First, I'm not going to bother about how many links are coming, but I'm just trying to talk about two input sources. I think Sharanya is trying to ask something. Sharanya, go ahead, please. I stopped you.
Yeah, Kiran.
Yeah,
Yeah. Uh, does this sequential file means like the input what we are getting like
text file,
um
text file,
database or
text file, text file.
text file?
Yeah,
Okay. It's
flat file.
just a text file, not database.
Yeah, flat file, flat file.
Okay.
So you can
So
have
what
a database as well, right? So I can bring the database as well.
okay, it's here. Okay.
Right. So based upon your source input data, you will take it. I'm just trying to show, the links. I'm just concentrating on the links names. That's it.
Okay.
Okay.
Yeah.
Okay, cool. So here, I'm just, let me, okay, here, left and right. So you will get a single output. Join stays inner join, left outer join, right outer join, full outer join, right? Yes. Join stays. When you can use the join stays, multiple data, high volumes of the data in case of both input sources. First input source, second input source, that is which is left source and right source having the high volumes of the data, unlimited volumes of the data. First of all, unlimited. unlimited volumes of the data. In case you can use it, that too, either one of the source is having high volumes, right? Maybe it is having that 10 millions of, otherwise 50 millions of the records, 50 millions of the records. It may be the 40 millions of the records. Otherwise, it is having that 50 millions of the records. I'm just giving the brief. Like just for generic, you can have your terabytes also, right? I'm just giving. Maybe this is having maybe 35 millions of the records. So here, what you understood is whatever the volumes, either this input may be having sometimes higher, this input may be having lower. This may be higher sometimes, and this maybe comes as lower. This is how your source you are getting the data. So unlimited volumes of the data, right? So at the same time, so you can use unlimited means high volumes of the data. In case that you can use it uncomparable data. Uncomparable means you don't need to compare. That's there is no difference, right? 35 where and 40 millions where, and 50 where and here 35. Sorry, 50 is where and 40 is where. So you cannot compare uncomparable data. Uncomparable data. Right? Unlimited volumes of the data or uncomparable data. In case you can use the joint stays. Right? So when you are into joint stays, first of all, what you have to do that when you can use the joint stays, that you have to come to the you have to think of when you have the volumes of the data in both the input sources, highly volumes of the data, first thing, and uncomparable data. So it is having 50 millions of the data, and this is 45 millions or 40 or 35, even below 30. Obviously, just go 50, how much 50 millions of the records. So don't go for any other stages, joint stays when you have two input sources. Because unlimited volumes of data, in the case, joint stays will work. Hello, I think I lost my audio. Let me connect again. Hello, hello, hello.
Hello?
You can hear me, right? Okay, okay.
Yes. No.
Some, I think Wi-Fi is not able to connect. Okay, that's fine. Fine. So joint stays can be used in any cases if you are uncomparable data, unlimited volumes of data in both the input sources. So you can use joint stays with any joint types. Okay, and mostly you are going to use in real time the inner join and left outer join. Not with this right outer and not with the full outer. You are going to work with, mostly you are going to get the requirement is I want the data of inner join, and so business will talk about this one, left outer join result. Then you will get into these outputs. What are the join types? Inner, left outer majorly. Right outer is very rarely, full outer very. In case I can't say that, you may get out. There is no chance. What is the usage of full outer? All the duplicate records and all the, just like a union, right? So in that duplicate records will be false. So everything. So but let's talk about now the volumes of the data. High volumes of the data, unlimited of the volumes of the data, and uncomparable. There is no comparison. It is maybe higher to lower, lower to higher. It's coming as. Then you can't decide it. You will business. You can check with that. Joint stays will be used case. So joint stays will release only maybe multiple inputs. Here two inputs only I have defined, but multiple inputs, single output. There is no rejection. You can use inner join means both in both input sources matching records. Inner join, what is the result of inner join? Matching records, right? Based on the key column, joining key. If you go for left outer join, all the records, matching records from both the input sources and all the records from left outer join. Understand? Hello?
Yes. Yes, yes, understand, Kiran.
So left out, like what I'm trying to say that, so matching records from both the input sources and all the records from left. Right outer join means, matching records from both the input sources, all the records from this one. Full outer join means, and just, all the records from both the input sources, total records, just like a Cartesian products, you can say that, but not exactly Cartesian. So you can say that all the records, say suppose 10, maybe in this also 10, but matching records will be there. Here at least 5 records are matching out of 5, and another 5 is going to be there. Total 10 records will be captured over here. So full outer means all the records from both matching and unmatched records from both the input sources. Then you will get single output, which is your join output. But majorly you will get inner join and left outer join in the business transformations. So now you have come to the conclusion, but I need to talk about the partitioning here. So when you go for partitioning methods, which partitioning in the link you have, you see here, sorry, I just used it. I must use in join states. See here, input source. This is the left, this is the right. So both inputs will have a partitioning. So obviously what I'm trying to say that you can use here auto, here you can use hash. So that means what you're trying to do, hash means you're making the grouping, similar records, inner join. If you are using the inner join or whatever it may be join, you're trying to join or you are making into the group similar records. That's how you can use auto, otherwise auto hash you can use it. It's up to you, but hash will be used. Hash partitioning you can use it for write. But I'll prefer to use auto. I'm just leaving it to Datastage itself majorly. When I have a high volumes of the data or low volumes of the data, always I'll keep it for this one, right? That's all. If you're trying to use single output, right? If I'm trying to use multiple outputs, it will scold you. See, the source test cannot support any more output links. That's the reason. Single output only. No more rejections. Say suppose some rejections. Matching records anyhow it will go. Some rejects records you want to capture in externally. It won't allows you other outputs. That's how join stage will work on. Right. Somebody is trying to ask something. Go ahead, please.
Kiran, it's Sagar.
Yeah.
Yeah, so earlier you said that in the business we'll mostly have inner join and left outer join, but
Correct.
we won't have much like of right outer and full outer. Is
Correct.
there any specific reason for that? I mean,
Basically, business needs matching data. Or all history, if you talk about history of the data, it's a current data. Say suppose left outer always will be current data, which is this is a historical data. That's good question, Sagar. Good question. Okay, always your this right link will be used as a historical of the data, your data warehousing. I mean, till today you are keeping the data, history data, but this left is going to be current data, daily data. You are comparing daily data to history of the data. Then what you require? Inner join, otherwise left outer join. Obviously, either same customers are existing with our previous data, I mean till yesterday's data, you need it. Otherwise, any new records are coming, you will pick from the left. Understand what I'm trying to say? That
yes, got it, understood.
yeah, that's the reason. Any questions from anyone? Sharanya, I mean Agastyan.
Okay.
No.
Okay, and Raghu. Raghu, you there? Raghu, if you are not clear, let me know, please. Okay, I'll be moving to the other part. Now we are done with the join stage. Okay, shall I keep it in here because you will not get confusion? Otherwise, I'll go with the other one, new window. Again, I'm just taking two inputs. I'm about to talk on okay, right. I'm just about to talk on this one. Lookup, right? About to talk on lookup. Lookup also will provide the link names. Now I'm just talking about lookup. Lookup. In lookup stage, just like a join stage, how many join types are available? 4, right? With the join stage, we can implement 4 join types. In lookup stage type also, basically just like when you compare with the results of join stage, only you will get inner join result and left outer join result. You will get only 2 results of join stage, just like a join stage, inner join result and left outer join result. But when you can use the lookup, yes, it's very clear. When you have first input source data, which is your input source, here naming convention will be the different. When you compare with the join stage, it will read as a primary input. What you will call primary link, primary input or primary. Okay, this is going to be a reference, but lookup will read as a lookup link. Getting or not? Earlier we used to call left and right? But lookup will read as a primary and lookup. When you got this primary first link, when you're touching to the lookup stage, obviously it will become a primary. Otherwise, this link, if you touch first time, obviously it will read as a primary. But I'm trying to touch here. So let me show you here. I'll be closing. So otherwise, I'll take it out. Lookup. See, I shall show you. If you go here, stage properties, link ordering, primary. So, but as of now, in the join stage link we have used, right? Otherwise, so I'll change it primary. See, the left it is showing that link name. Otherwise, link name like number CDS link 8 or something, it must do so. Otherwise, I'll give you brief one. You will not get confused. I'm just taking a lookup first. I'm using a sequential file. So I'm not touching as of now to the lookup stage. So you wanna use Oracle connector stage as a secondary. I'll use it. See here, please. When I'm trying to touch either this one or this one to the, see, obviously it will become a primary. You wanna see again? Primary. Then how come second one? It will become a lookup link. Lookup link is nothing but a reference link in our general terminology. Reference, only for reference, not for, so primary link always will be the higher priority, which having the historical data. So here vice versa. In join stage we are using this one as a current data, or this maybe you can use the current data, which is a historical data. When you are comparison inner join and left outer join, right? Sagar, I was talking about. Here, most of the cases, this is going to be a lookup or reference link, which is a current data, which is a historical data, which is a current daily data. So that's the reason it will be read as a secondary link always will be dotted line, which means reference. It's a primary, right? This link you wanna see? So this is going to be DS link 28 going to be show as a lookup link. Sorry. See, lookup one. So that means number of references, just like in joint stage we have seen that, right? Intermediate links, just like that you can see it. Okay, lookup, lookup, lookup one. Okay, so as of now I'm just using lookup. So number of lookups you can use it. So this is going to be second. Lookup 1, lookup 2. Lookup 2. Lookup 1, lookup 2. Lookup 1, lookup 2. See, number of lookups you can use it. Number of references you can use it here. But as of now I'm trying to show with the two input sources only. Okay, right. Primary and lookup 1. Okay, come to the conclusion now. So when you can use the lookup means, yes, maybe limited volumes of the data or unlimited volumes of the data, mostly limited volumes of the data. You can use unlimited means joint stage, right? Limited, you know that volumes of the data, you can easily compare. So you are going to check count of rows from the input table name, count of rows of this one, right? Limited or unlimited also sometimes. Columns, right? Sorry. Columns. And limited volumes are unlimited columns and comparable data. Comparable means easily you can compare it and it's going to be comparable data between the sources. Say I was talking about here some 10 millions. This is going to be a 5 millions. So lots of gap is there. And maybe always your lookup data will be coming as a 6 million sometimes, maybe daily, or 7 millions, or 8 millions, or 9 millions, below 10 millions. Not more than that. So that means your primary is always higher than your lookup data. This is standard. You can check with your business. You can confirm. You can talk to them. Your customers or on-site coordinates who are be the part of. So the competition between the joint stage and lookup stage here. When you have this situation comes, you need to check with your counterparts on-site or your client or customer. You can have a right. You have a right to ask them. So I'm going to use joint stage and lookup stage. Can you confirm us whether the production is having? They'll check it in the production volumes of the data. So based on that, they'll confirm it. Yes, always primary data will be higher. That means first input source is higher and second input source always is in lower. We have checked from past 2 months or 3 months or 1 year data. So always lookup data, secondary sources, they'll not say that lookup. They'll not say that you have to use lookup and you have to use joint stage. They'll confirm you the volumes of the data because they also they'll not give you that confirmation on that which stage you have to use. So how come then developer, how you will become a developer, how they can't be developer? That's the reason they're going to give you the confirmation based on your positions. Understand? So Obviously, your primary source is higher volumes of the data. When you are comparing with the lookup data or reference data, is always higher than just awesome stages, lookup stage than join stage. Better than join stage, it will work in a fast and quick performance wise. It's very used stage is lookup stage. When your primary data always higher than reference data. So this is a lookup stage. You can use it in lookup stage also. You have. So that's the reason lookup stage will have a lookup memory. Lookup memory. Inside of the lookup memory, always lookup memory will give you the preference. Give the preference to the primary data. 10 millions of the records will come into the picture. Here 9 millions of the records. Now it will take into the 9 millions because so it will have mainly primary data, it will invite to the 9 million. Now the comparison will start 1 to 1, first record to first record of the secondary source, 1 to 2, 1 to 3, like 1 to 9 million, again 2 to 1, 2 to like that, 2 to 9 million. So if in case your secondary source is having some 11 millions, how come? Because primary lookup is going to be having the preference to the primary data. 10 to higher volumes, it's very difficult. Lower to higher volumes is very difficult for the lookup stage. Your job is going to be get aborted. Your performance is going to be degraded. Job is also going to be degraded. If you are using lookup stage, this kind of a situation. That's the reason always your primary data should be higher than your reference data or lookup data. Then you can use lookup stage. Then whenever your primary source data is having higher, obviously your primary data volumes will be here. And reference data you have to invite. Then you can use entire partitioning. Entire means all the records of reference data you are using. One second. Right? Understand, right? What I'm trying to say? Sharanya, Agastyan, Sagar, Raghu?
Yes,
Yes, sir.
Kiran.
Right.
Understood, Kiran.
Yeah. So whenever you have this data is lesser volume than your primary data, better always stage is go to lookup stage. And lookup stage also will have inner join result and the left outer join result only you will get it. But naming convention will be there different. In not inner join and not left outer join, the naming convention will be different. You will get to know this. What are the naming convention and all. But try to understand the concept. So when you have that lookup stage, single output just like a join stage you will get it. Other than single output, you have one more chance is one reject output link. Only one reject. Which are not matching records between those two input sources, obviously you will have this reject output link. So two outputs you can get it. One is the primary output and another one is the reject output. Always reject output would be the dotted lines. Sorry, right? So this is how the condition you can use it. You can check with your customer when you have supposed to use when you have a dilemma. So which one you have to use, join or lookup? So let's confirm us the volumes of the data between the primary source to secondary source. You can check with that. They'll confirm you. So always we cannot say that the volumes are going to be different. Then obviously you have to use join stage. But if they confirmed it, our first source is always primary source always. This is the source name is going to be there. Tell you some department table. Department table always will be having higher volumes than employee table. Right? Then just use it based on that. They'll tell you. Okay. So lookup memory always. Lookup memory will be preferred to use only for primary data. That's the reason you are inviting low volumes as a entire by using the entire partitioning. Here you can use auto partitioning for the primary input data. Auto here entire. So obviously it's good to go if you have this kind of situation. Good to go with the lookup stage rather than join stage. Very performance wise very perfect. Lookup stage when primary data to primary data to lookup data when you compare lookup data always should be the lower. Sometimes small variations will be there. Small variations. Here 10 millions, maybe 10.1, 10 lakh, 10 million, 1 lakh record. Small, higher volumes. Still you can use the lookup stages. Still you can use the lookup stages. So then your performance is going to be degraded, but still you can have a chance to use the lookup stages. Maybe it may works. Otherwise, some situationally it's degrade your performance of the job. What I'm trying to say that maybe sometimes primary data to lookup data, when you see that maybe small variation, because comparable data, I'm using the comparable, means small difference may be variation, you can use the lookup stages, but don't use it even though. That's the reason, based on this, I'm going to define two types of lookups. One is normal lookup, second one is the sparse lookup. Normal lookup is standard. Your primary data is always higher than secondary. This is higher than always this. This is always higher than this one. Then normal lookup. Sparse lookup is small difference. Sparse lookup is somewhat. This is higher than still you are using. That's lookup is going to be called sparse lookup. But try to avoid using sparse lookup. In case of this situation, go with your joint stage. Don't use sparse lookup. Understand? Understand, guys? Hello?
Yes.
Yes. Don't
Karen.
try to use sparse lookup. Right? This is how the sparse lookup we can talk about, and lookup types also available inside of the lookup stage. There is a range lookup, key column, key lookup, so caseless lookup. That's inside of the lookup stage. That we don't bother about it. When we go for the stage, we'll see that. Now talking about the merge stage, third processing stage. Third processing, merge stage is awesome. Merge stage also just like a joint stage. Whatever the volumes of the data, it may be higher, this may be lower, this may be higher, this may be lower. So obviously it is instead of prime. So in joint stage, what you have seen that left and right. In lookup stage, primary and reference are lookup. Here master in merge stage, master and update. Reference will be called as update link. Okay, just a moment. Right. So you can use, right, merge stage in any cases, like higher to lower or lower to higher. You can use the merge stage. Merge stage can be having the n number of references if you are using, update, right? I'm talking about updates. Here references are nothing but update 1, update 2, like that you can use it. So let me try to show you. I'll be deleting this one. I'll bring that. Same files only. I'm just taking. Nothing to worry. I'm using. Number of things I'm just pulling it up for merge stage. Same join stage, lookup stage, merge stage. You will get a single output, but the regex are going to be different. In join stage, you don't see the regex, but in lookup stage, you can see single reject. But in merge stage, you can see multiple rejects if you have multiple references. And this will become a primary, right? In lookup, this will become a master. If you want to see link ordering, master, and remaining will be references will be update 1, update 2, update 3, like this. Understand or not? If we have number of this one, obviously single output will be there, right? That is standard for join, lookup, and all. And if you are comparing with the master data to master, this is going to be master. Master means historical data. This one update 1. This is update 2. Right? Update 1, which are not matching records from master to update 1, this will be rejected here. Master to update 2, obviously it is going to be rejected here. So a number of updates are you are having, and number of rejections you can make it. You want to see link ordering, master, update 1. Here you can see here reject. Update 1 goes to the reject. 43. See here, update 1 should goes to the reject 43. Update 2 goes to the reject 45. You can change it. It's not like that, update 1 should goes to the update 43. You can check it, you can down it. So update 1 now you can go to 45 also. Update 2 goes to 43 also, vice versa. It all depends. But master should goes to the 40. Understand, right? 40. That's how your design will be there. Just like a join stage, you can use it, but merge stage we don't use much cases. The competition between only both two stages, that is join stage and lookup stage. That's how you have to remember. That's it. Any questions here? I'm just winding up the session for today. Any questions you can raise up? Let's meet tomorrow. Hello, Sharanya.
Hello.
Yeah, Sagar, Agastyan, Raghu. Any questions here?
No,
Just
nope,
go through
not.
the video. Go through the video. You will have some questions. I don't think so. Every pinpoint answer I gave you. Conclusion. If you have the questions, we'll talk tomorrow. Right?
Okay.
All right.
Yeah.
Right. Okay.
Yeah.
Thank you, guys. Thank you, team.
Bye.
Yeah.
Thank
Bye.
you.
Sharni, I'll be sharing this recording.